Hello, grade 8 math. This is Mr. Josh coming back to you to review and learn understanding linear and nonlinear functions. Linear and nonlinear functions. So, guys, right off the bat, linear and nonlinear functions. Linear functions, this has the word that we're looking for in it. It's a line. If you see a function that involves the solutions that are that of the function that make a line on a graph, that's a linear function. If it's anything but a line, if it's a squiggly, if it's almost a line but it's a little bit curved at the end, these are non-lines or non-linear functions. All right, but now the kind of picture or the picture is obvious, but there are some other ways to distinguish the patterns of these functions that will tell us if it's linear or not without even using a graph. So let's look at this first way. First, let's get some vocabulary underneath our belt. The ratio of the changes in two quantities, such as the slope of a linear function, is a rate of change. So we're used to slope, right? Slope is the change in change in y divided by the change in x. The rate of change is the same thing as the slope. It's the change in the output values divided by the change in the input values. And remember, guys, our output is always the y values. Our input is always the x values. So rate of change is the same thing as slope. But when we talk about functions, we talk about rate of change instead of slope. Really, they're interchangeable. So how can we tell if a function is linear? How can we tell if a function is linear? That means it has a straight line as a graph. And the way we can do that is by finding the rate of change. That is, finding the slope of the function. So let's say that we're given this table, okay? And remember, they're finding the rate of change. You're finding the ratio of the y. That is, how does the y change compared to how does the x change? Well, think about this. How does the x change from 1 to 3? That's a plus 2. How does the x change from the next one? 3 to 5. That's a plus 2. And you can keep doing this. 5 to 7 is plus 2. 7 to 9 is plus 2. So the rate of change, remember, the rate of change is my input values is on the bottom. Remember, x is my input, guys. So input is on the bottom. So the way that x changes is every 2. How much does y go up or go down? Y goes up plus 6, plus 6, plus 6, plus 6. So every time my y changes by 6. So every time my x changes by 2, my y changes by 6. Now we could simplify that and say, you know what, both of these are actually divisible by 2. So I'm going to divide both these by 2, and I get 3 over 1. And there is my rate of change. One thing to note here, is this linear or is it nonlinear? Well, linear functions always have a constant rate of change. Now, what does that mean? Constant rate of change. That means that when you simplify the ratio of the output over the input in each point, in each change, 6 divided by 2, if that is the same between each point, so let's check it again. 6 divided by 2, that's going to give me 6 divided by 2 is going to give me 3. Again, 6 divided by 2, 6 divided by 2 is going to give me 3. Notice that my rate, each variable changes, is the same each time, right? These are all the same. So if you see a function that is constant rate, that is, it doesn't change, then it's linear. See another example. So let's say that we're given this table and say, is it linear or nonlinear? Well, remember, we want to find the rate of change, which is the change in output over my change in input. Remember, your change in output is y, your change in input is x. So we want to figure out, okay, let's start with the x's just because it's on top. So from 1 to 2, that's plus 1. From 2 to 4, that's plus 2. From 4 to 7, that's plus 3. And from 7 to 8, that's plus 1. Now, you might think to yourself, oh man, Mr. Josh, Mr. Joseph, these are not constant, right? Well, before you say anything, let's check the change in the y values. So from 18 to 12, that's a minus 6. From 12 to 0, that's a minus 12. From 0 to 8, negative 18, minus 18. And from negative 18 to negative 24, that's a minus 6. So now we have to compare the rate of change for each different x and y shift. So remember, we want to do y over x, which is equal to, well, the change in y there is negative 6 over positive 1. Negative 6 over positive 1. So when I simplify that, that gives me negative 6. So there's my rate of change for that first shift. Now, in order for it to be a linear function, each time I simplify it, it has to simplify to negative 6. So let's check it out. So I have a plus 2 and a negative 12. So it's change in y over change in x. So it's negative 12 over 2. Now I can simplify this, and I get negative 6. Notice it's the same as before. Now, the fraction is different, negative 12 over 2, but when I simplify it, it simplifies to the same quantity. All right, let's check the next one. I have 3 and I have negative 18. So I have a negative 18 because, again, we want to do y divided by x over 3. That gives me a negative 6 again. Last one. So now they've been all constant. This is a constant rate of change. For every x so far, when x goes 1, y goes negative 6. Let's check to see if this last one works out. So here's this last one. I have a plus 1 for my input. Remember, it's input's on the bottom. So plus 1 on the bottom. And then my output's on the top. And that is a minus 6. So minus 6 divided by 1 is a negative 6. And you can see that it's the same as before. So in each case, we have a constant rate that the y's and the x change. So we can say that this is a linear function because the rates are constant. Let's look at another one. Again, we want to find the change between each variable. So 1 to 2 is a plus 1. From 2 to 4, it's a plus 2. From 4 to 7, plus 3. 7 to 8, plus 1. Now, before we jump to any conclusions, we've got to check each y value. From 1 to 4, it's plus 3. From 4 to 16, it's plus 12. From 16 to 49 is 33, plus 33. And from 64 to 49, that's 15. Okay. Now we want to know, does each of these have a constant rate of change? So we'll check 1 and 3. And hopefully at this point, you can think to yourself, okay, this is the change in y over change in x. So my change in y is, sorry, I'll make this one yellow, my bad. My change in y is 3 over my change in x is 1. So this right here is going to be 3. In this next one, I have plus 2 and plus 12. Well, that's going to be, again, change in y over change in x. So my change in y is 12 divided by my change in x, which is 2, gives me 6. Now, let's pause. You can see that 6 is not the same as 3. So if the rates are not the same, then it is a non-linear function. So the function does not have a constant rate of change. And constant rate of change means that they change at the same amount each time. And if it's not a constant rate, then we can say it's a non-linear function. That is to say that the graph, when we graph the solutions here, you will not be able to draw a straight line through it. You'll have to curve it somehow, some way. So if a function has varying rate, that means different rates, then it is non-linear function. And that's how we tell if a function is linear or not, by looking at a table. Catch me on the next video to continue talking about linear and non-linear functions.